Good afternoon, boys and girls. This is Mrs. Jacobs. I will be showing you two lessons today. All right, so if you need help with the second lesson, 11.2, then you should fast forward this video. Okay, so this is introducing chapter 11, which is all on angles. And the two lessons that I will be teaching is 11.1. I can relate angles and fractional parts of a circle, and lesson 11.2, I can name fractional parts of a circle using degrees. All right, so those are the two lessons that this video will be about. So we're going to start with 11.1. And introducing 11.1, we have two vocabulary words that are really important. It's clockwise, is the direction the hands move on a clock, right, to the right, right? The hands move to the right. Counterclockwise is the direction opposite from the way the hands move on a clock, right? So the hands would move to the left, right? So those are two important vocabulary words to help us with today's lesson, at least one part of it, okay? So I'm going to show you what counterclockwise and clockwise mean, and then we're going to talk about some fractional parts of the circle, which we're going to call turns. Okay, so first we're going to look at a clock, and we should know that on a clock we can look at it as a fraction of a circle, and we just happen to use a clock because there's hands on a clock to help us relate to angles or turns, right? So in this clock we can look at it as a circle and cut this circle into 6 equal parts, 4 equal parts, and so forth. Okay, so we're going to cut this circle into 4 parts. Okay, so I'm going to cut it in half, and then I'm going to cut it in half going horizontally and then vertically. Okay, so we have 4 equal parts. Okay, so this is 1/4, 2/4, 3/4, 4/4. And why this is important is because it helps us with turns. And when I say that is because if we want to see a quarter turn, right, we're going to start here and end here because that will bring us to the 1/4 mark. Okay. If I want to go a half turn, okay, again, I start and I keep on going until I get to the halfway mark, okay? And same thing for 3/4 and 4/4, obviously, is around the whole entire clock. And this is important because this helps us with turns. And if you understand at which point that we're stopping, so I will show you turns on a clock in the following slide. We're going to use this tool, okay? It's a clock, but I'll be able to move the hands on it and be able to show you and move the hands and show you how we get the turns, okay? So just hold on. We need to get to this website and we will begin. Okay. So we'll wait for, okay, so here we go. Here is the clock, okay? Right now it's at 12 o'clock. I will only be moving the minute hands, all right? Because one hand right now is going to stay at 12, okay? And again, clockwise is to the right, okay? Counterclockwise is to the left, okay? So I'm just going to show you turns right now, okay? So watch this. Quarter turn. 2/4, also known as a half. 3/4, and then eventually back to the whole turn. So 1/4, 2/4, which is a half, 3/4, whole. Okay, and now that's the turns, okay? So if I was to go counterclockwise, I would do this. Move to the left. 1/4, 2/4, 3/4, whole. Okay? So it's very important to know what direction you're going into. That's the counterclockwise and the clockwise. Then, once you know which way you're turning, you'll have to decide how much are you turning. Is it 1/4, 2/4, which is a half, or 3/4, or a whole turn? Okay? So I'm going to show you right now 2 examples. I'll show you quarter turn counterclockwise. So that means going to the left, and only 1/4 turn. So that's 1/4 turn counterclockwise. Then I go back, right, to 12 o'clock. And now I'm going to show you 3/4 turn clockwise. Clockwise means I go to the right. So 1/4, 2/4, 3/4. Sorry about that little message. Okay, so this is how the hands on a clock help us with turns. Okay, so before we start identifying the turns on the circle, we have to look at fractions and shaded parts of a circle, okay? And this is a little bit of review of fractions using circles. So number 1 is asking us, okay, tell what fraction of the circle the shaded angle represents. So we're always looking at the shaded part. So if I look at this, I see my circle in number 1, and it's cut into 2 equal parts, right? So this is 1/2, and this is 1/2, right? But it's asking for the shaded angle represents. So this is a straight angle, okay? And the shaded part represents 1/2. So that is the answer to that, number 1. Number 2, again, it's shaded area, okay? And looking at this circle, okay, I don't know what the denominator is, okay? So I like to follow with my pen to create the part. Sorry, that's a little crooked, okay? So I really have 4 parts on this circle. So 1, 2, 3, 4, but 3 out of the 4 is shaded. So this is 3/4 is shaded. Okay, so sometimes it's hard to visualize because they're only giving the one angle or the one shaded part. You don't get to see all the other parts. So you might have to create them. Okay, same thing on here. I do this. This board is a little off today. All right, so again, 4 parts, but only 1 is shaded out of the 4. It's 1/4. So here, okay, I'm looking at this and I'm thinking about fractions of 1 whole, okay, and this looks like to me 1/3, okay, because remember we have to make equal parts. So this is 1/3, 2/3, 3/3, but only 1/3 is shaded, right? Now for this next one, I have no idea, right? So I'm going to try to recreate all the parts that would be on this circle, right? So I'm thinking that if I do continue that, now that's not equal. We need all equal parts. Then I do that, that. I know. So remember, we're trying to make equal parts. So this looks the closest to equal parts. And I count the parts, 1, 2, 3, 4, 5, 6, 7. There's 8 parts, 8 equal parts, and only 1 is shaded. So that is 1/8. Okay. So sometimes we have to go draw in to make sure that our fraction is correct. All right, so here's a question. Which shaded angle shows 1/3? Okay, so I've sort of did this one. All right, and obviously we use the process of elimination. This shows me 1/2. This shows me 1/4, right? Remember doing this? And this shows me that looks smaller than 1/3. So now, right now, I think it's B or D. So I want to continue with these arrows, right? So I'm going to continue up with this, right there. I want to continue with this one, okay? And then, nope. This is 1/6, okay? And this, guys, if you did this, right, and then you did, oops, this, you could see that those are not equal parts, so you can't do it that way, okay? So we have to be able to make equal parts. So doing it like that, okay, we get somewhat of an equal part, which is 1/3, all right? Okay, so let's look at now the turns, okay? So tell whether the angle of the circle shows a 1/4, half, 3/4, or 1 full turn, clockwise or counter. So we have 4 examples here, but I want to focus on the highlighted words, clockwise or counterclockwise. We decide that first. And what decides that is the red arrow shows you which way we're turning. So that's very important. So according to this red arrow right here, okay, that's what I'm looking at, shows me going to the left. So right now, to the left is counterclockwise. So I know the direction. I'm going to abbreviate, okay? And now that I figured out which direction, I have to figure out the turn using the 2 rays right there. So I could see that it went from here to here is 1/4 turn. So it's 1/4 turn counterclockwise. All right. So again, looking at the red shows I'm starting here, and I'm just going to follow it. And if I trace it, I could see that this is going in the right direction. So this is clockwise. Okay. Now I have to look at the starting point and ending point. So I have here all the way around in here. So it's a full turn. So full turn, 1 full turn. Okay. All right. Next one, I have to figure out the direction. This is going to the right. So this is clockwise. And the turn is I'm starting here and going 1/4, 2/4, which is a half, right? So half. Right? Next one, do the red. Starting here, and if you notice, I'm tracing, and it's going to the left. So that's counter. Just going to write counter for now. And I know that it is, if it's going this way, it's 1/4, 2/4, 3/4. So this is 3/4 turn. All right. So again, I'll show you a few more, and that'll be it for today's lesson on 11.1. Okay, so tell whether the angle on the circle shows 1/4, 2/4, 3/4, or 1 full turn, clockwise or counter. I always like to do which way, clockwise or counterclockwise first. Okay, so I'm looking at this, and I'm just going to use a different color. Okay, and I see this is going to the left, to the right. Right, so starting and moving like a normal clock. So that would be clockwise. I know it's clockwise. Now I have to figure out the turn. So it goes like this. All right, so first of all, it's 1/4, 2/4, 3/4. So this is a 3/4 turn clockwise. Okay, here we have it going this way. So that's to the left. So now I know it's counter. I'll do CW for clockwise. Counterclockwise. And now I have to know how much it's turning. So watch this. It goes from here to here, has only changed 1/4. All right, let's look at the direction. It's to the left. Oops, counter. Clockwise. Turn. Okay, you got to go to the left. So it's 1/4 is here. 2/4 would be here. 3/4. So this is 3/4. Counterclockwise. Looking at this picture, I know it's a full turn, and it is going to the left. So this is full turn, counterclockwise. And then on this one, I could see it's a half turn, but now I have to decide if it's clockwise or counterclockwise. Let's see, it's going to the left. It's counterclockwise. All right, next one, I see it's going normal, like a normal clock, to the right. So I know that's going to be clockwise, but I don't know how much. Well, this shows right here 1/4. This is 1/4 turn. All right, so it takes a little practice, okay, but this is how we tell whether the angle on the circle shows a 1/4 turn, half turn, 3/4, or 1 full turn. Okay. All right, so let's just answer this question. If this was a test prep question, use the diagram to answer the question. So I always like to go to the diagram, okay, and mark it all up, obviously. And I know that it's going from here to here, so that's going to the left. So I know it's counterclockwise. So if it's counterclockwise, this can't be the answer. And this can't be the answer. See, process of elimination. So now I have to realize, is that 1/4 turn or 3/4? So I'm going from here to here. It's that's 1/4. 1/4. Okay? So nope. Answer is B. All right. Which angle shows a 3/4 turn counterclockwise? So what I like to do is find the counterclockwise first. I feel that is easier. So I'm really looking for arrows that go to the left, right? So this one, if I trace it, it's going to the right. No. If I trace this one, oh wait, this is going to the left, so this could be a possibility. This one is going to the left, so this could be a possibility. Up. This one's going to the right, so no. So now I'm left with B and C. And now I really can identify it because I know B is half, right? And I'm looking for 3/4, but just to make sure, it goes like this. 1/4 stops here. 2/4 would stop here. 3/4. Okay, so nope. C is the answer. I could have bubbled it in. I circled it. All right. Okay, so that is the lesson for 11.1. Now we're on to 11.2. I can name fractional parts of a circle using degrees. All right, so today we were introduced to 4 vocabulary words, which are 4 types of angles. So we might be asked to classify. Classify means sort them. So you need to be able to identify what each of these angles look like and their measurement in degrees. All right, so we have a acute angle, and like today I said in class, a acute angle has to be greater than 0, because if you have 0 degrees, you actually don't even have an angle. So it has to be 1 degree and less than 90. So any degree from 1 to 89 is an acute angle. Okay? A right angle measures exactly 90 degrees when we have that square corner that we talked about. That square corner automatically identifies a right angle, which is 90 degrees. Obtuse angle is an angle that measures greater than 90. So 91 all the way up to 179 is an obtuse. And then we have a straight angle, comes from a straight line, and it looks like a straight line. It measures exactly 180 degrees. So these are the four angles that you need to know the vocabulary, be able to identify them, okay? And draw them eventually, okay? All right, so today we're going to think of a circle divided into 360 equal parts. Now that's really hard, right? We could do a circle in 2 parts, 4 parts, 6 parts, 8 parts, 12 parts, but 360 is a little too much, right? So we need easier ways to identify parts on a circle, okay? And we're going to be looking at those fractional parts of a circle today, and we're going to turn them into degrees. So we are going to make a fraction of a circle equal to an angle measurement degrees, all right? So just a little important information. An angle that turns through 1 out of 360 of the circle measures 1 degree. An angle that turns through 90 out of 360 of the circle measures 90 degrees. So I'm seeing a little pattern here, okay? So when the denominator is already 360, the numerator tells you the angle measurement. So 1 degree, 90 degrees. And that's very important because really no work has to be done when the denominator is already 360. We just look to the numerator and that tells you the measure of the angle in degrees. So I put 3 examples here. Okay, denominator 360, check. Numerator becomes your degrees. It's 45 degrees. So 45 360ths is a fraction, but now we just turned it into degrees. All right, 270 360ths. So again, 360 is the denominator, so that means 270 is the angle measurement. And don't forget the degree symbol. Okay, and then 125 over 360. This becomes your angle measurement, okay? So this is pretty straightforward. If the denominator of your fraction is already 360, you look to the denominator and voila, there's your angle in degrees. However, the angles shown in this lesson do not always have a denominator of 360. Of course they don't. So when the fractions do not have a denominator of 360, we need to make equivalent fractions. So we got to put a little work into it, all right? So what does that mean? So that means, for example, this is a fraction, okay? Let's say 1/4. That's a fraction, but the denominator is not 360. So it is our job to now make 1/4 an equivalent fraction to have a denominator of 360. So equivalent fraction, and now we need to make it have a denominator of 360. Okay? And then we fall back on our knowledge about equivalent fractions. And we know that since we're going from 4 to 360, we're going to use multiplication. So 4 times what number would give me 360? I know 4 times 9 is 36. So now I add the 0 is 90. So if I multiply the denominator by 90, I must also do that to my numerator, which gives me 90. So the answer to this is 1/4 is equal to 90 degrees. And we'll do a few examples. Okay, so let's do 1/12. Okay, again, that denominator is not 360. So we have to make it an equivalent fraction to get the denominator of 360. Why? Because we want to make it easier ourselves and just look to the numerator and say, oh, that's the measurement. But we can't do that if the denominator is not 360. That's why we're making equivalent fractions. Okay? So 12 times what will give us 36? 3. Add 1 0. So again, I'm going to go multiply the numerator by 30. And I get 30 over 360. And again, just like before the lesson, if the denominators are 360, then the numerator is the answer. Denominator is 360, the numerator is the answer. So 1/12 of a circle is equal to 30 degrees. All right. And we'll do one more. Let's say the numerator is not 1. All right, so let's do 2/9. Okay, that's a fraction. Okay, the denominator is not 360. So we have to make it an equivalent fraction equal to 360. Okay. So 9 times what will give me 36, which is 4, and that becomes 40. So then we multiply the numerator by 40, and we get 80. And now we can say, wow, the denominator is 360. So I'm going to look to the numerator. So 2/9 of a circle is equal to 80 degrees. Right? So here's a little review of what I just said. All right, this is from the reteach. Okay, it shows you that in the top part, if it's already denominator of 360, the numerator is your answer. So if we're looking over here, look, check 360, 50 degrees is your measurement. So this would be 50 degrees. But if I go down to the second example, I look at 1/6 and I say, oops, 6 is not in the denominator of 360. So I have to make it equivalent to the denominator of 360. So if we look at the work right here, okay, we make it to a denominator of 360, right, by 6 times 60. So multiply 1 times 60. And then finally, look at the numerator. So we'll look here, right? So we look at the numerator, and it's right there. So the numerator tells you how many degrees are in 1/6 of a circle. So 1/6 of a circle is 60 degrees. So this is a 60-degree angle. They're referring to this angle. That's 60 degrees. This one is a 50-degree. And using our knowledge, these are both acute angles. See how they all come together. All right, so then we're just going to look at these 4, and then we're done. Okay, so the first thing I'm going to do is I'm going to scan these problems, and I'm looking for the ones that have a denominator of 360 already. All right, so let's look. Oh boy. The only one is number 1. That already has a denominator of 360, so all I need to do is look at the numerator, and that tells me how many degrees? 39 degrees. So this angle that's represented here is 39 degrees. Now, unfortunately, number 2 is not, the denominator is not 360, so therefore we're going to make an equivalent fraction. All right, so I'm going to do 1/5 equal to 360, and I say, oh boy, I don't know my 5 times tables all the way up to 360. So I could go over to the side. 5 times what will give me 360? I don't know. So let's divide. All right, when in doubt, divide, right? So I'm going to divide, and 5, 7, 35. Subtract, bring down 2. Okay, so it's 72. So you might have to do a little work. So 5 times 72 will give me 360. So what I have to do, 1 times 72 gives me 72. So again, 360, yes, look to the numerator, 72 degrees. All right, number 3 is 1/8. So again, I'm going to say 1/8 equal to 360. All right, now I have to do some division because I don't know my 8 all the way up to 360. So I'm going to do my division work to figure it out. So 360. So 8 times 4 is 32. Subtract, bring it down. 8 goes into 40. 5 times 8 is 40. Subtract. So it's 45. So it's 8 times 45. So then I multiply the numerator by 45 and I get 45. So again, 360 answers the numerator, 45-degree angle. So that's a 45-degree angle, which is half of a 90-degree angle, actually. All right, and now 5/12. So again, it's all about making equivalent fractions when the denominator is not already 360. All right, so 12 times 3, so that would be 30. And then I'm going to do times 30. It's 150. So it's 150 degrees. So 5/12. And so then after doing all that, I could fall back on my knowledge about identifying and classifying angles as acute, obtuse, right, and straight. So if I look at number 1, 39 degrees, it's acute. If I look at number 2, 72 degrees is acute. 45 degrees is acute. And number 4, 150 degrees is an obtuse angle. All right, so that's how we can combine everything together. So 11.1 was fractional parts of a circle. 11.2 is changing those fractions to degrees and identifying whether they are acute, obtuse, right, or straight. And that is it for the lesson today. Sorry for its length. But however, you may use this as you see fit, maybe for parents, tutors, or even studying for your tests or quizzes in the future. Okay, thanks for joining.